All right, let's do this thing. Whenever I had you guys watching those lectures yesterday, it was the biggest cringe fest of my life. I hate listening to myself on those things. Okay, so what we didn't get to yesterday was subtracting rational expressions and simplifying complex fractions. So we're going to do some examples of that. Let's do subtracting rational expressions. And let's do an easy one at first. Let's say we have 1 over x, and we are subtracting 2 over x plus 2. The first thing we need to do is we need to find some sort of common denominator. So you'll do this little guy over in the corner. You'll say, okay, I've got an x and I've got an x plus 2. So my LCD is going to be those things combined. It's going to be x and x plus 2. So x times x plus 2. Also, when in doubt, if you don't really know what the denominator is going to be, go ahead and multiply them together and then you can simplify later. So if I'm trying to get x times x plus 2 in the denominator of 1 over x, what do I need to multiply the numerator and the denominator by? Yeah, x plus 2. Least common denominator. You have not been watching the lectures. Love you, but you have not. That's how you spell it, my dude. You write that down. Well, it's important though. You have to know that. Then we're subtracting 2 over x plus 2. What do I need to multiply my numerator and my denominator by in order to get x times x plus 2 in the denominator? Jesse? Not quite. So we need to get x times x plus 2 in the denominator. So what's missing? So there should be another x. So I'm going to multiply my numerator and my denominator by x. See how that works? So that whenever I simplify, put this guy in a little box. I'm going to have x plus 2 in this numerator. I'm going to have x times x plus 2. And now I'm subtracting 2 times an x and x times an x plus 2. Do we see how we have a common denominator now? Now we can combine those things. So now you put it all over the same denominator. Like that's the point, right? Is that we don't want to have a bunch of fractions running around. So now we're going to have x plus 2, and we've got to use that negative to have a negative 2x all over, sorry, x times x plus 2. We can simplify that, right? Because we've got a negative 2x. So what's going to be in my numerator after I simplify? Well, so we've got a negative 2x and then an x. Well, so we've got positive 1 and then we've got negative 2. Yeah, it's going to be negative x. So negative x plus 2 all over x times x plus 2. So I want you guys to try one really quickly. I want you guys to try 1 over 2x minus 4 over x plus 3. First step is find your LCD. That's all from there. So we figured out that our LCD is going to be 2x times x plus 3. So Emma, what do I need to multiply my numerator and my denominator of 1 over 2x by in order to get that common denominator? Well, we're just going to do x plus 3, right? Because then that'll get us 2x times x plus 3, which is what we want. Now I have minus 4 over x plus 3. So Jesse, what do I need to multiply the numerator and the denominator of that by? 2x. Very good. So now I have x plus 3 all over 2x times x plus 3. And I'm subtracting 4 times the 2x with 2x times x plus 3. I can put that all over the same common denominator of 2x times x plus 3 and have x plus 3 minus, what is 4 times 2x? 8x. The simplified version of this is going to be what in the numerator? I've got an x and a negative 8x. Yeah, so I'll have negative 7x plus 3 all over 2x times x plus 3. Now, the only thing is, if you remember from yesterday, if you watched the lectures from yesterday, we're not quite done. We also need to find the points of discontinuity. And the first thing you do is, when is my denominator the longest or the biggest? And then I'm going to set that equal to 0 to solve. So when is the denominator biggest? And set it equal to 0 to solve. So it's visually the biggest when we have 2x times x plus 3, and we set that equal to 0. You have two things being multiplied together. You have 2x times x plus 3, and so you can actually do this, where you have 2x is equal to 0 and x plus 3 is equal to 0. It's the same idea as factoring. So how do I solve for this one, Jesse? Do what? I can't hear you, I'm sorry. Yeah, wouldn't x be equal to 0? Because I divide 2 on both sides. Very good. Of course it kicks off whenever you're done talking. Okay, and do you want to help me with the next one? I've got x plus 3 is equal to 0. Very good. So yes, this is technically the correct answer, but you also need to include when x is not equal to those points of discontinuity. So in this instance, it's when x is not equal to 0 or -3. This whole thing is your answer. So it's really easy to forget this step, but it's important to make sure that your equation is defined. So let's do a harder one. Let's say that we're looking at x plus 2 all over x squared minus 2x. And we are subtracting x plus 2 all over 2x minus 4. First, let's find our common denominator. Is there any way we can simplify x squared minus 2x?
Yes.
Yeah, what is that? What do both of these terms have in them?
X.
X? So both have x. So what I'm going to do is I'm going to pull that x out, and if I pull one of my x's out of x squared, what do I have left, Beals? Very good. If I pull x out of 2x, negative 2x, then what do I have left, Colton? If I pull x out of negative 2x, what do I have left? Negative 2. All right, now let's look at 2x minus 4. Are these both divisible by something? Do they have something in common?
Yes.
What is that?
2.
2. So I'm going to pull that 2 out. And if I pull 2 out of 2x, Emma, what do I have left? Mm-hmm. And if I pull 2 out of negative 4, what do I have left? Mm-hmm. Mm-hmm. Okay, so it looks like if we make our little houses and we have x squared minus 2x, and I put off from the side, we have a factor of x, we have a factor of x minus 2. And if I look at 2x minus 4 in the little house, where I pull out a factor of 2, a factor of x minus 2, what is going to be my LCD?
X.
Yep, there's going to be an x.
And 2.
There's going to be a 2.
And x minus.
Mm-hmm.
Times x minus.
And then we have 2 of these x minus 2's. So I'm just going to use one of those. So that is the goal of what we need to get in all of our denominators. So let's do it. I'm going to rewrite these orange guys in a way that we're used to seeing. Which is just what we did, where we just factored. So what do I need to multiply my numerator and my denominator by in order to get this denominator to be 2x times x minus 2? Anyone?
2.
2? That's the only thing that's missing? So I'm going to multiply this by 2 and multiply this by 2. So if I'm trying to get this denominator to be 2x times x minus 2, Jesse, what do you think I need to multiply the numerator and the denominator by? Bx. That's the only thing that's missing, right? So let's write that out. So I've got 2 times x plus 2 all over 2x times x minus 2. I'm subtracting x times x plus 2 all over 2x times x minus 2. As long as you're good with it, I'm going to go ahead and erase this stuff off to the side here. And I'm going to go ahead and combine these guys. So I'm going to say that I have 2 times x plus 2. I'm subtracting x times x plus 2. And this is all over the common denominator of 2x times x minus 2. At this point, learning when you can distribute, when you should and when you shouldn't, that's kind of a hard thing to learn. But in general, it's probably a good idea for you to go ahead and try and distribute so you can see if you can cancel things out. So let's go ahead and do that. So I've got 2 times x and 2 times 2. So what is that going to give me, Emma? Mm-hmm. And then I've got a negative x times x and a negative x times 2. So what is that going to be, Olivia?
Negative x, or negative x squared
Mm-hmm.
minus 2x.
Yeah, so make sure that you distribute that negative. And that's all going to be over 2x times x minus 2. Let's try and simplify that. Do I have any like terms, Colton? No. So do I have anything that can maybe cancel each other out?
2x negative 2x.
Yeah, 2x and negative 2x. So what is that going to leave me with? I'll have negative x squared plus 4.
Just x.
Well, so I still have this 4, right?
Yeah.
And that's all over 2x times x minus 2. Now, a lot of you guys are probably going to stop here, and I won't blame you, but this isn't technically the right answer. This isn't simple enough. So do you guys remember in your notes where I said x squared minus a perfect square? Do you remember this?
Mm-hmm.
Factors to be x minus the root and x plus the root. So one of the tricks that we can learn is there's a negative here, but there's a positive here. And I need to make that second one a negative. So what I'm going to do is I'm going to distribute out, factor out that negative. So I have x squared minus 4 with a negative sign out from it. And put that all over 2x times x minus 2. Now we can factor that, right? We can factor x squared minus 4. What is that going to be, Emma? Mm-hmm.
Negative x squared.
So
Oh, wait, never mind.
it's okay.
Negative x.
So we have x squared minus a perfect square. So we have x squared minus 4. What is the square root of 4? So it's going to be x.
Minus 2.
Mm-hmm. And?
X. 4.
So it's going to be x minus the root and then x plus the root.
Oh, plus 2.
Very good. And that is all going to be over 2x times x minus 2. Now, is there anything that we can cancel here, Jesse? Is there anything that's the same in the numerator and the denominator? X minus 2. So what am I going to have left, Olivia?
Negative x plus 2.
Mhm.
Over 2x.
Ta-da! Now that is the answer. I hid a couple little tricks in there, so hopefully whenever you're looking at other problems, you can realize that. So notice a couple things. Notice that the common denominator for these guys wasn't to multiply them together, okay? There's actually an easier way. Notice that you only had to multiply 2 and x to each one of those. So instead of multiplying one of these by 2x minus 4 and multiplying the other one by x squared minus 2x and distributing and all of those things, sometimes there's an easier way. And then another thing is always try and see if you've got an x squared, if you can factor, so you can cancel even more and get an even prettier answer. So now we're going to be simplifying a complex fraction. And I've got a couple examples of this. So one example is if we had something like 1 over x divided by x over 3. If we have two fractions that are being divided by each other, that is going to be the same thing as 1 over x divided by x over 3. Now notice one thing, there is no addition or subtraction. So I want you to put no addition or subtraction, okay? That's how this works. That's why it's okay for us to go ahead and put it in this new format. If we're dividing fractions, that's the same thing as multiplying by the what? Yeah. What's the reciprocal of x over 3? Yeah. Now we know how to do that, right? Whenever you multiply things together. So what's going to be in my numerator? 1 times 3 is 3. X times x is x times x squared. That's the answer. Now notice there was no common denominator. Why is that? That's because we're multiplying. So anytime we multiply or divide, we do not need a common denominator. I had some people on multiplication questions on their quiz trying to get a common denominator, and it was getting really nasty really fast. So just take note of that. So let's see an example where you are like maybe adding something. So let's say that we have 1 over x. We are adding x over y. And that is all over 1 over y. and we're adding 1. There's lots of different instructions in here. So let's take a second. With all of these fractions going around, we need to find a common denominator. So you need to write off to the side what is going to be my little LCD. So I've got X in one of my denominators. I've got Y in another denominator. I've got Y in a denominator. And then what's in the denominator of 1? Mm-hmm. 1 is the same thing as 1 over 1. So I technically have 1. So if I'm trying to find my common denominator, I'm going to multiply the things together that are the same. So it looks like I've got an X. Looks like I've got a Y. That Y repeats, so I'm not going to use that. And I've got a 1, which this will just simplify to XY, because XY times 1 is just XY. So for this guy, we are going to be multiplying our entire numerator by our common denominator of XY. And we're going to be multiplying our entire denominator by our common denominator of XY. This is where it kind of gets a little complicated, but follow me because it's really not too bad. So I'm going to have 1 over X times XY. I'm adding X over Y times XY. I've got 1 over Y times XY. And I'm adding 1 and multiplying that by XY. So I just distributed that XY out to each of those individual components. And the simplified version of this is going to be XY, I'm going to put XY over X plus X times XY over Y. I'm going to have XY over Y. And it looks like I'm going to be adding 1 times XY. So let's look at the orange first. Out of XY over X, is there anything that's the same in both the numerator and the denominator?
X.
X. So if I cancel an X out of the numerator and the denominator, what do I have left?
Y.
So in my X times Y over Y, do I have anything that's the same in the numerator and the denominator?
Y.
Y. And so if I cancel out that Y, I just have X times X, right? What is X times X?
X.
Then I have Y plus X squared. When I'm looking at XY over Y, Emma, do I have anything that can cancel an XY over Y? The Y, so what's going to be left? X. And then I have 1 times XY. So that's just going to be plus XY. This guy is your answer. Does this make sense or are we totally lost? Makes sense so far? I know it's a lot easier whenever like I'm helping you through it, right? Versus whenever you're doing it by yourself. So it's understandable. But those two examples had to do with questions, I think 4, 5, and 7, maybe on your homework. And I'm going to let you have through Monday to turn in that homework. Okay. So now let's do 8.6. Rational equations. Fun, fun. This is basically what we've already been doing, but we're putting an equal sign in there. So these examples really shouldn't be too terrible. We're just taking all of the things that we've learned over this chapter and smushing them together. So an example of this is x over x minus 3 plus x over x plus 3 equals 2 over x squared minus 9. I see a bunch of fractions. So what I need to do is I need to get my LCD. And I use LCD instead of LCM here because it has to do with my denominator instead of a multiple. But they're this exact same process. So my denominators, I have x minus 3. I'm going to make that a little house. I've got x plus 3. Make that a little house. And I've got x squared minus 9. Can we simplify any of these? Can we factor any of these?
X squared minus 9.
X squared minus 9? Because we have a perfect square minus, well, we have x squared minus a perfect square. So what is that going to factor to?
X plus 3 times x minus 3.
Yeah, because it's a square root of 9. And it's just the plus or minus version of that. So if we're trying to find the LCD, I'm going to go through and I'm going to circle one of each of everything. So in each of my little houses, I have an x minus 3, but I have another x minus 3 over here. So I'm just going to use one of those. And I've got an x plus 3, but I've got another x plus 3 over here. So I'm just going to use one of those because we're not using any of our duplicates. So our least common denominator is going to be x minus 3 and x plus 3. So let's see this in action. If I've got x over x minus 3, what do I need to multiply my numerator and my denominator by in order to get x minus 3 times x plus 3 in the denominator?
X plus 3.
To get in the denominator, because we're trying to get x minus 3, x plus 3, this is the part that we're missing. And then we are adding x over x plus 3. So someone else, what do I need to multiply my numerator and my denominator by in order to get x minus 3 and x plus 3 in the denominator? X minus 3. Oof. You guys okay if I erase this LCD stuff?
Mm-hmm.
Now that is going to be equal to we're not changing anything on the right-hand side. We're not multiplying the numerator and the denominator by anything. But I am going to rewrite it in kind of the way that we're seeing it across the board of that x plus 3 and x minus 3. These are the exact same thing. I just factored it. So let's go to the orange. If I distribute that x out to that x plus 3, what am I going to have in the orange numerator, Jesse?
So the x squared
Very good. X squared plus 3x. And that's all still going to be over x minus 3, x plus 3. So if I distribute that x out to x minus 3 bills, what am I going to have? Let's start with x times x. X squared. So it's not going to be times because we're subtracting. Yeah, minus 3x. Very good. And that is going to be equal to 2 over x plus 3 and x minus 3. Now here's the really magical part. All three of our terms, so 1 term, 2 term, 3 terms, they all have the same denominator. So guess what happens? It cancels. So the point of getting that common denominator is so if we cancel out all those denominators, what we have left is x squared plus 3x plus x squared minus 3x is equal to 2. Now we know how to solve that, right? So what are some like terms that I can combine, Colton? Some like terms? X squared? So if I combine my x squareds, what do I get? I have x squared plus x squared.
2x squared.
Mm-hmm. And then I have plus 3x and minus 3x. So what is that? That's 0. So we're going to have 2x squared is equal to 2. What's the next step in solving this guy?
Divide 2 by both sides.
Yeah, divide both sides by 2. So I'm going to have x squared is equal to what? 1. So Emma, how do I finish out this problem? I've got x squared is equal to 1. How do I get rid of a square? Does anyone want to help her out?
Square root.
So we're going to do the opposite of a square by taking the square root. So the square root of x squared is x, and the square root of 1 is 1. So all of that. And finally, we get answers that we're used to seeing. X is equal to a number. So I want you guys to try one. The one that I want you to try is going to be y over 5 plus y over 2 is equal to 7. First thing you need to do is find your common denominator. totally paused my recording and I stink. So we found our common denominator of 10. We multiplied numerators and denominators by 2, 5, and 10 in order to get our common denominator. We canceled out our common denominator, and then this is just all pre-algebra stuff. And now we're taking our quiz. Whee!